that's permutation. Counting where the order doesn't matter, that's a combination. Where I need any set in any order. Let's look at combinatorics when it applies to probability. What I want to focus on this week, at least for the first couple of days, is using combinatorics to find the probability of given types of events. We're going to look at poker hands. We're going to look at Powerball. All different types of things. If you have a calculator, make sure you know how to use combinatorics on your calculator. It's going to save us a lot of time here today, too. So let's try this. On the board behind me, the center console of my car has a bunch of different coins in it. Right now it's got 5 quarters, 6 dimes, 8 nickels, and 4 pennies. How many coins are in my console? 23. Keep that in the back of your head. I'm going to reach in and I'm going to grab 3 coins at random. How many ways can this be done? Order doesn't matter. I just need any 3 from how many total? 23. So the combinatoric would be 23, choose 3. All right, if you have a calculator, let's just get that typed in. 23 choose 3 is 1,771 ways. We're going to start talking about probability in these next 3 questions. Probability is what I want to happen divided by, in total, how many ways it can happen. Favorable over total. We just calculated the denominator. When I start doing probabilities, I like to build it from the bottom up. Think about how many ways there are for something to occur before I think about what I want my favorable outcome to be and finish up that probability. Now, number 2, what's the probability of selecting 2 dimes and a nickel? My 3 coins are 2 dimes and a nickel. Let's find the combinatorics for this outcome. How many dimes are there in the console? 6. I need any 2 of them. So 6 choose 2 should give me the number of ways to choose any 2 dimes to start my 3 coin selection. The nickel, I want 2 dimes and a nickel, so let's multiply times the combinatoric for how many ways there are to draw the nickel. I think there are 8 nickels, and I need any one of them. So 8 choose 1. Choose 2. Choose 1 for the nickel is 168. This would be what I want to happen. There's 168 ways to select 2 dimes and a nickel from the coins in the console out of how many ways in total? How many ways are there to draw any 3 coins? So my probability would just be 168 divided by this number we found in part 1, the 1771. So the probability of this event is 168 out of 1,771. If you want to write that as a decimal of percent, that's about 9.5%, 0949. Moving on, some other different types of scenarios. What's the chance that my 3 coins, anybody need lunch? Okay. What's the chance that my 3 coins contain 2 or more quarters? So I need 3 coins, 2 of them are quarters, the other one was what? Not a quarter, right? So 1, not a quarter. How many ways can this happen? Where I have 2 quarters and something else, right? How many quarters are in the console? Looks like there are 5. So 5 choose 2 gets me any 2 of the 5 quarters. How many not quarters? How many non-quarters are in the center console? There were, what, 23 in total? 5 of them were quarters? That sounds right. 18. So I need any 1 of the 18 non-quarters. 18 choose 1. We had 5 choose 2 times 18 choose 1. Looks like 180. That's to get 2 quarters. What else could I have drawn if I get 2 or more quarters? All 3 quarters. That'd be 5 choose 3. I choose 3 looks like it's going to be 10. So the probability of getting from the 3 coins 2 or quarters would be the sum of these 2 outcomes. 180 ways to get 2 quarters, 10 ways to get all 3 quarters, divided by 1,771 different total combinations. So 190 out of 1,771 looks like about 10.73%. Another multiple option scenario here. What if I want at least 1 penny? How many pennies could I have selected if at least one of them would have been a penny? I could sit here and find all the ways to have either 1, 2, or 3 pennies. What else could I do to be a little bit more efficient? And then subtract it from, well, not 1 in this case, all the total ways to draw them, right? I think I'd rather find that than doing 1, 2, and 3 pennies and adding them all together. So at least 1 penny is equal to the total number of draws minus the number of draws where no pennies would have come out. Well, total number of ways that this can be done to select 3 coins from the 23 in total, I already have. That was just part 1 back here. That would be 23, choose any 3. I want 3 coins where none of them are pennies. How many non-pennies are in the console again? 19, because 4 of them are pennies, leaving the other 19 to not be pennies. So let's subtract. Choose any 3 of the 19 coins in the car that are not pennies. It's like 802.
Sí.
So my probability of at least 1 penny is the 802 ways to draw either 1, 2, or 3 pennies we found by taking the total number of combinations minus the ones that have no pennies in them. Out of the 1,771 ways in total that I could draw any 3 coins. About 45.29%. A little over half time, you're going to have at least 1 penny in your hand. All right, let me turn you around. Let's look at some more probability scenarios. They're all a little bit different, but they all involve combinatorics and are some good review and practice from our work last week. Okay, that's hard. Grouping students. I have 12 juniors and 4 seniors. How many people is that? 16. I'm going to split that into 4 random groups of how many students? 4 groups of 4, right? 12 juniors and 4 seniors are split into 4 random groups of 4 students. Find the chance that each group has 1 senior. So I split the 4 seniors evenly across each of the 4 groups. When I start doing probability, I like to do it from the ground up. So let's think about all the number of ways that I could arrange these 4 groups. What are the total number of ways to pick the 4 groups? I'm starting with 16 people. Let's make the first group. How many students are in the first group? 4. So 16, choose 4. Now I've got the first group. I need to find the second group. How many people are eligible to be in the second group? 12. So it's 12, choose 4. For the third group, there's 8 people remaining. And for the last group, there's only one way to do it. But I'll write it anyway. 4, choose 4. It's like there's 63,063,000 different ways to arrange the groups. Now let's figure out the number of ways where each group has exactly 1 senior. Let's place the juniors and seniors into each of these 4 respective groups. For the first group, there are 4 seniors, and I need any one of them to join the group. How many juniors are eligible to be in this group? How many juniors are there to start with?
Well,
How many of them do I need to be in the group?
3.
3. I'll get that on the calculator here in a minute. Let's do the next group. Isn't there 1 less senior now? So it's 3 seniors left. Choose any one of them for the second group. How many juniors are eligible for this group? 9. So I need any 3 of the 9s juniors eligible for that group. Now it should look pretty familiar as this pattern here. For the next group, it's 2 choose 1 for the seniors, 6 choose 3 for the juniors left. The last group kind of is already formed for us. There's only one way to pick the 1 remaining senior, and one way to choose the 3 eligible juniors. So let's see, we had 4 choose 1 times 12 choose 3. Like 880. Let's change this to 9, 3, and 9. 252. 40. And this last one is going to be 1. There's 880 ways to choose the first group, 252 ways to choose the second group, 40 ways to choose the third group, and only 1 way to choose the final group. What do I want to do with these 4 respective combination totals? Do I add them, or do I want to multiply them? I think I need to multiply them. So I need this and this and this and this to happen.
Yeah.
So I need to multiply all those respective combination totals together. So 880 times 252 times 40 times 1. So 8,870,400. So my probability is just that number out of the 63 million ways to start. Roughly a 1 in 8. (13.94%). Okay, let's do this. I've got an example up here for you guys to finish up with, and then we'll talk about your work, check our answers when we're done. Would you try this probability? Tomorrow we're going to talk about Powerball. The game of Keno at a casino is very similar. To play the game of Keno, players select 5 numbers from 1 through 80. They're going to pick any combination of 5 numbers. The casino selects 20 random winning numbers from 1 through 80. You want to match 3, 4, or 5 of those winning numbers. If you get 3 numbers correct, you win some money. If you get 4 numbers correct, you win more money. If all 5 of your numbers are correct, you hit the jackpot. You win the most money. What's the chance that you're going to win at least something, winning a game of Keno? Let's find the total number of ways to get started first. I want to find all the combinations of winning numbers. How many numbers are there in the total game? How many winning numbers are there? 20. This is going to be kind of a big number, so I'm going to use a different calculator than one you have. Total combinations of winning numbers would be what combinatorial? This is going to be a big number, so I'm going to use a different calculator. I typed that in on this screen. You probably found this scientific notation on your calculator. This is just the expanded version of it. Big number. Let's see, I've got 3, 5, 3, 5. 316, 142. 212, 174. I'm going to. You don't have to. 300.
I'm ready.
There's that many combinations of winning numbers. Figure out the number of combinations to pick any 3, 4, or 5.
Do you have to like, guess this in the right order and everything?
Nope, it's any combination. You can get any 3 of the 5 to match and win, any 4 of the 5 to match and win, or all 5 of the numbers that you draw to match and win.
Can you imagine if it had to be the same order? Making it possible.
Yeah, that'd be a losing proposition. It's like the Powerball. You go to buy a Powerball ticket, you just pick numbers as long as you match them. I think the Powerball is different. You have to match the Powerball. But the white balls, you can match anywhere.
What would you do? 20 choose 3,
Mm-hmm.
and 20 choose 4.
Ooh, what are your? I gotta get 5 numbers. I've only picked 3 of them to win with.
Oh yeah, you guys have
How many numbers did I lose? If only 3 of them were winners.
2.
2. How many losing balls are there? How many losing numbers are there?
60.
60. If there's 20 winning numbers in the game, wouldn't that be 60 losing numbers in the game?
So you have to. So then you do.
And then
So you do. So the first one you do 20 choose 3 times 60 choose 2.
Because if I hit 3, that means I didn't hit 2 of them.
Yeah.
There are 60 numbers that are losers if there are 20 numbers from the 80 that are winners. I think there's different games of Keno, but I think you could actually like win your money back if you get like 1 or 2 of them right. Just depends on how the game is set up.
Did you play this game?
Would I play Keno?
Yeah.
No. I don't really like to play casino games because the odds say that I'm not going to win any money. You can get lucky, but in the long run, you're not going to win.
What happens if you get lucky?
Well, then you had a good day.
So,
If I go to a casino, I played blackjack before. I like to play blackjack.
I like blackjack.
Slots are the worst game to play at a casino.
That's all I can.
yeah, it's the machine.
Exactly.
Brings it.
The more decisions that you can make, the better overall that game is going to be in your favor.
Blackjack should be like,
Blackjack and craps are usually the 2 best player advantage games.
so let me just keep going down the line, 20 choose 4,
Uh-huh.
20 choose 5.
And then do you add all these?
You do. Because you could have this or this or this. I want the sum total of ways to select either 3, 4, or 5 of the winning numbers. And means multiply, or means to add. What is that number? 3 billion trillion? 3 quintillion? We'll do Powerball. Maybe poker too.
How do people even move the Powerball? It's so low.
Takes a while.
Magic.
I bought a couple Powerball tickets. I've never won any more than like $10 though. Get one white number right,
Jack,
or
you
get the
can't.
one red Powerball right.
What?
Jack, you can't buy Powerball tickets.
They always put for like scratch. I don't know. I always get something like that. And, like,
Little scratcher
Yeah.
ticket.
I think most of them is like. It'd be like 18 miles.
No, I think it's 21.
Is
Is it 21 now? It changes sometimes.
Yeah, scratchers are my favorites. My dad
Yeah.
always has.
Always buy a couple scratchers.
And then you would divide. So you divide
Yep.
that.
You take that, whatever that is, but then you divide by this number to start with. It's going to be probably pretty small. Let's get this figured out. I have 3 winners, 2 losers, 4 winners, 1 loser, or all 5 winners and no losers. So let's get the combinations for 3 wins and 2 losing numbers. That would be 20 choose 3 times 60 choose 1. Choose 2, pardon me. 4 winners and 1 loser would be 20 choose 4 times 60 choose 1. And all 5 winners would be 20 choose 5.
Ooh, we are really, really, really tiny number.
Yeah, you're not going to win very often. That's if there's anything I teach you for the next couple days, it's don't gamble. 2,017,800.
Yes, your first Clash Royale legendary.
Oh, legendary. That's silver chest.
Yeah.
Let's see here, 20 choose 4, and 1 way to lose, 2,9,700.
Silver chest.
And then 20 choose 5. Team 504. So all told, there are this plus this plus this number of ways to win. Let me add those up. We have 2,017,800 plus 2,9,700. 504. So 2,324. Divided by, I'm going to write this out one more time. Did anybody divide this?
Yeah.
It's probably pretty small, isn't it?
Yeah, it's like
6.57368084 times 10 to the negative 15. Except rather than writing that out, I just did.
I'm not even going to convert it to a decimal.
I just did 82's 20 again.
Yeah, that'll be fine.
kind of tricky.
I'm not even going to convert it to a decimal because I'm sure it's probably in scientific notation.
Based on what it takes, it kind of tricks you into thinking it's easier.
Sure. I think most Keno games, you can win with 1, 2, 3, 4, or 5. You just win less by getting less number of correct numbers. Like if you get 1, you might get your money back. If you get 2, you get a little bit more, and so on. Okay, let's do this then.